Okay, so we have talked about various aspects of OSPFv2 single area implementation. The final piece of this puzzle is to verify what it is that you think you have done. So we're going to talk about verifying OSPF, um, verifying the protocol settings, verifying its process information, and finally verifying your interface settings. Um, So that's what we're going to talk about in this next video. I'm going to run back to the beginning of these four things, and this will be the end of this section of the video lecture. Just a second, I'll be right back. So as we've discussed previously, the OSPF neighbor relationship is the foundation of everything else that happens in the routing domain. Uh, if if something doesn't look right, start here. Um, If everything looks right here, great, you can move on, but you've also confirmed, yes, this is working. The command here is show IP OSPF neighbor. And you will see all the neighbor relationships that it has, their current state, their priority, if they have one. These all have a priority of 0 because they're all serial lines. There is no DR, BDR to mess with, so everything's fine. The state of the thing is, of course, should either show full or two-way. Your dead time will show how much longer that neighbor relationship has to persist if no more hello packets are received. Of course, every hello packet has its own uh, uh, refreshes that dead timer just a little bit, so that ideally the dead timer never hits 0. The address, of course, is the neighbor's directly connected interface. And you will also see its physical interface. So in this case, router 1 is talking to router... Okay, so the interface in this case, sorry, I misspoke. The interface in this case is the local interface through which that neighbor relationship exists. So there's that. And let's see, so the next thing is to verify our protocol settings with the show IP protocols command. So move myself just a little bit. So show IP protocols. You should be good and used to this by now. You'll see your router ID, you'll see your protocol and your process number, you'll see the networks that it is routing for and the areas that it's in. You'll see how many areas it's in. For a single area OSPF, this should be 1. You'll see the routing information sources, their distance and the last time they were updated. If, for example, one of these has been modified a little bit so it has a non-standard distance, it'll show up here. This is another good place to check. Now, the thing that we don't see here, because it hasn't been implemented this time, but it could be, in here between your routing for your networks and your routing information sources, if you have any passive interfaces, they'll show up right here. So there's that. Let's talk about the process information. If you do show IP OSPF all by itself, you look at the process. You'll see its ID, you'll see when it was started, how long it has been up. You'll see, you'll see all the different kinds of routes that it is exchanging. And here down at the bottom, you'll see fun things like what kind of area it is, if it's a backbone. The last time the SPF algorithm was run, how many areas it has, how many interfaces it has in the area. You'll even see reference bandwidth, and so on and so forth. The final thing you can look at is your show IP OSPF. There's actually 2 forms of this command. So there is show IP OSPF interface, which will give you lots of details about one specific interface, roughly analogous to the show IP interface command you would see in v4 with the plain Jane v4. For example, if you wanted to look to see if an interface has ACLs on it, do show IP interface. If you want to do show IP interface brief and look at all of them at the same time, you can do essentially that with show IP interface brief. You'll see the interfaces, you'll see their process ID, their area, their address, their mask, their cost, their current state. notice that the serial lines are in the point-to-point state, which explains why they are um, in a full state rather than two-way state. You'll see how many neighbors they have, and here at the bottom we see your gig 00. It is in a DR state. It is the designated router, but it has no neighbors, so effectively that does us no good. We see, if we notice also here, we can sort of guess or, sorry, we can surmise, shall we say, what the auto cost reference bandwidth is, because our gig 00 has a cost of 1. That tells us that our auto cost reference bandwidth is either set to 10,000 or to to 100 megabits or 1,000 megabits per second. So either a fast Ethernet is our reference bandwidth or gigabit is our reference bandwidth. Now there's also a lab in this section, which I have already done a video series about setting this lab up. If you watched that first, we would probably have discussed some of this already. If you have not watched that first, go ahead and watch that, particularly if you're interested in specific aspects of this, verification, setting your router ID, basic configuration, etc. I think I did about 4 videos to go through that lab. Thank you for watching, and we will move on to single area OSPFv2 next. Thanks.